Before we jump to coding, right, it's important you know the concept first. So it's a good idea to understand the diagram first. If they understood why we want to use double-ended double link from part 2 video, right, now let's look at how to construct a linked list starting from the small component first. Let's look at this tiny box. We call it as ListNode. Inside this box, we can store a data inside. We use a word pointer because a word pointer is a generic pointer that can store the address of any data type, like integer pointer, double pointer. But keep in mind, the data we store must be malloc because it needs to retain in memory. Since we pass the linked list between different functions, you cannot store the local variable. Example, int local is equal to 2. If you store the address of local what happened when the function n is, the variable also get destroyed, then you lost the data. Next, our list node got two pointers to store the address of the next list node and the previous list node. So we can start with typedef the struct of the list node lah. So we got the value variables with void pointer. And this is called as self-referential struct, where the next and previous pointer can store the address of itself. As you can see, this tag list node pointer having the data type of tag list node. Finally, for readability and I don't like to type out the asterisk, right? Here is the tiny trick. You can direct typedef the pointer by giving it a name. The syntax is like this. After the comma, you write an asterisk, then followed by the data type name. So next time you can direct use this data type like this. With that, we have completed our list node. For convenience, we want to write a function to initialize the linked list and return the address of the linked list. As this linked list needs to keep in the memory, we need a struct and typedef the struct pointer also. Now let's write the struct of the linked list. As we mentioned, we want two markers, the head and the tail, so that we can insert or remove the first and last list node faster. So the data type is list node pointer to store the address lah. We add another variable called as count because it is very useful. Example, when we want to iterate to get the second item or the last second item. So the function to initialize the linked list is, first we malloc the linked list. Second, we set the head and tail to null. Third, we set the count to 0. With that, we have finished the backbone of the linked list. There are two situations you need to consider when implement these four functions. Your linked list can be empty like this, or your linked list can have data already. So example, initially it's empty. When we insert first A, we need to check if it's empty. If it's empty, then we need to set the head and tail to store the address of the list node A. Similar to insert last, if it's empty, we set the head and tail to store the address of list node A. So the result of insert first A and insert last A will result in this diagram. Now when it's not empty, right, let's look at insert first B. We are going to use head for the first node, a temporary variables. If you are not sure what to do, right, look at this diagram and think what are you going to do. So we are going to store the first node address to the B next, right? And then store the B address to the first node previous. Lastly, we store B address to the linked list head. That's all. Similar to our insert last B. If you insert last B, you will put the new list node at the back. So we are going to use the tail for the last node, a temporary variable. If you are not sure what to do, look at this diagram and think what are you going to do. So we want to store B address to last node next, right? And we store the last node address to the B previous. Lastly, we store the B address to the linked list tail. We have done. When we do removing, right, we will return the list node value. That's why you can see it is a word pointer. For removeFirst and removeLast, first, if it's not empty, you need to check one more condition. Whether it is remaining with only one list node, this is important. Let's look at removeFirst. If it's not empty, our node value is our first node value. The first node next address will store to the linked list head. If there's remaining one item, we just set the tail address to null. Else for this condition, we set the null to the new head previous. Now let's look at removeLast. If it's not empty, our node value is last node value. The last node previous address will store to the linked list tail. If there's one item, we just set the head address to null. Else, for this condition, we set null to the new tail next. Okay? With that, we have finished cover our linked list. For increment and decrement the count, right, I leave it to you because it is very easy. Thank you for watching. If you have any question, please ask, yeah.